Okay, does everyone get their, okay, perfect. All right, welcome teachers to Educator's Edge, Enhancing Instruction. Today we're talking about TEK 3.6c, Changes in States of Matter. And there we go. Okay, those of you that are watching this asynchronously, please make sure that you have these items available before moving forward. If you don't have them, please pause and gather them before moving forward so you can be sure to participate along with us in our investigation today. I am Kristen Conrad, Elementary Science Specialist, and I'm joined with two of my fabulous science ISTs. We have Amy Snyder and Jenna Hudon, who you will hear from shortly. Our learning outcomes for today are one, by the end of this session, you will understand the targeted standard, the 3.6c. We are going to analyze assessment questions covering this standard. You're going to experience a lab, and we're going to review some instructional resources that you have available to support you in teaching this standard. These are our norms for the session. If you can please keep your camera on, that would be much appreciated. Use the chat to participate when we provide questions. And if you have any questions, feel free to drop them in the chat. We'll address them at the end of the session. And just honor the session time by staying until the end and making sure you fill out a feedback form. And if you're watching this asynchronously, make sure you go back and take your quiz to get your teacher choice hours. And we are going to jump in by looking at historical data. 3.6c is one of a few third grade TEKs that are actually assessed on the STAR. So I only had Northside data for 24 and 25, and in 2024 that TEK was not assessed, but it is historically assessed. I believe before that it was assessed in 2022. But you can see last year in 2025, our district scored, we had 39% of our students pass this TEK. And looking at last year's unit assessment data, as a district, 33% of our students got the unit assessment question covering the standard correct. So those are pretty low numbers, which is why we're here today, because this TEK is identified as a hotspot for science. And so we're trying to just do everything we can as a district to make some academic achievement growth in this area. So we're going to start by unpacking the TEK. So as you can see, this is a lengthy TEK. So I'm going to give you and your team a minute to read the TEK. And to unpack the TEK, I'm just going to ask that you identify the verbs and then the content. So let's start with the verb. So read over the TEK with your team or by yourself and identify the verbs. And if you'll just drop those in the chat as you find them. Okay, we've got some verbs coming in. I see predict, observe, and record. Excellent. And now if you'll look at what exactly is it that they are to predict, observe, and record? What is the content piece of the standard? So if you just want to drop in a couple of key words or phrases that kind of hit some of the content pieces to the standard, that would be much appreciated. Changes in states of matter. Good. When heat's added or removed, solids, liquids, gases. Excellent. Very good job. And you can see below the standard, you have the learning targets that are in your curriculum. We kind of took the TEK and broke it into pieces just to simplify and kind of guide you through the sequence to work through the standard. So they will be predicting, observing changes when heat is added or removed from solids, liquids, and gases. They're going to use safe practices. to investigate these phenomena, and they are going to use digital scales and thermometers to measure mass and temperature. So they're going to use some tools and safe practices as they work through this TEK. So let's take a look at how this standard is assessed on your unit assessment. So there's one question, and this is it. So I'm going to give you a minute to look over it and with your team discuss what impacts, like knowing this is how it's assessed, how does that impact your instruction? What do you need to make sure your students know how to do, and what information do they need to know to be able to be successful on this question? And I meant to check and I forgot, but I believe on CMS, where you see the blanks in the sentence, I believe it's like an inline response where they're drop down boxes with the choices. Okay. So, just a couple of things that stick out to me are obviously the words in the word box are going to be key vocabulary to make sure your students know how to use and are familiar with. But I do notice the question says the water changed from A to A. So having students explain that to you, like, when we boiled water, the water changed from a liquid to a gas. Or when we put water in the freezer, water changed from a liquid into a solid. So having them use kind of that sentence structure to describe what's happening, and then always including because, and always bringing attention to if heat was added to create that change or if heat was removed to make that change. And then also making sure students understand that condensation and evaporation are processes. So when they get to this question and it says this process is called, they will be able to recognize that this process is called evaporation. So that way the word process won't be new to them. So I think looking at this question before providing instruction gives you some key things to keep in mind when teaching. And then then this is what the TEK looks like on the fifth grade star. I'm sorry, it is no longer the fifth grade star. This is what it looks like on the elementary science star, grades 3 through 5. That is its new name. So again, I'm going to give you a minute to look over this with your team and just kind of talk about what do students have to be able to know and do to be successful on this question. And if you guys want to drop any of your ideas in the chat, feel free to do so. Okay, and on both questions, I'm getting some vocabulary needs to be understood. And I want to be careful because there's a lot of vocabulary needs to be understood first. And so, of course, by the time you get to an assessment piece, right, we're looking at a unit assessment. So, of course, that vocabulary must be known by the time you get to the unit assessment. And of course, the vocabulary should definitely be known by the time you get to the star. But even I think before the vocabulary is known, the whatever the content is, it has to be experienced first, right? You don't want to just give them vocabulary and definitions. You want them to experience that and then follow up with the vocabulary. And we're going to look at that here coming up soon. Some pieces I want to make sure you are aware of is if you have students doing this in third grade, you are setting them up for success in fifth grade. If you're having students pay attention to the temperature and identifying if it's adding heat or removing heat, and then collecting detailed observations, then you are preparing your students for this level. I did think it was interesting to pay attention to the detail in the observations. So they didn't just observe the ice cubes disappeared. They said the ice cubes disappeared and only liquid was remained in the beaker. And then for the answer, which is C, the water in the beaker begins bubbling and the amount of water decreases. So to me, I'm like, okay, like I know that we show them boiling water and evaporation, but do we always take that water and show them how much water we put in? And then do we look at how much water we have left over after boiling it to see that the volume of water does decrease because we lost it to evaporation? So that's an impact on instruction. If you're already doing it, just bringing the attention to one more piece. And you'll see in our model lesson that all of these pieces are addressed in this lesson. So you will be set up for success. And with that said, I'm going to stop sharing and Jenna's going to take over with the model lesson. Okay,
Okay, got my audio set. I'm going to share my screen one with you. Thumbs up. Do you see the chili changes, heat happenings, Canva? Beautiful, yay. Okay, so I'm going to walk you all through the chili changes and heat happenings exploration today. As you can see in the title there, it's been adapted from Ames. So if you're familiar with the Ames chili changes, if you so happen to carry that out in the past, we've taken that, we've adapted it, and then we also added the heat component because like you heard Kristen say, to really carry out that teak with fidelity, we have to have the application of heat for the changing state of matter. And in this substance we're using is water here. So you heard that word substance within the teak, and the substance we are going to use here is water, and have that water then change states by doing different things to it. So I have this view up because I want you to see the notes section here. Do you see the notes section on the left-hand side? And so for those who might not be familiar, to get that notes section, a lot of our Canvas involve notes because we just provide you with guidance in that sort of way, right? On the bottom left corner, there's a notes button. So if you click notes, then it'll pop up. Now this slide doesn't have any notes in it, right? But I want you to see as I go along with you that notes are going to pop up here and they'll be there to support you. So I am going to carry out this exploration with you. Sometimes when we carry these out, we talk to you like you're the student, right? But I'm really going to be purposeful about talking to you like you're the teacher, because there's going to be moments where I explain content. But remember, this is an explore for our kiddos. And so when we are carrying out an explore, we're not explaining the content yet. We're not assigning that academic vocabulary. And so I want to be explicit in sharing with you that at times I'll say, okay, this is for your knowledge as a teacher. But remember, we would not share this with our students yet because they are currently experiencing in an explore, right? They're making that background knowledge. They're having this shared common experience for you to then attach the learning to later on. So I just wanted to make that explicit. So here on this slide, you see our guiding question: how can substances change when heat is added or removed? And so that's the question that we will have guiding our investigation and that we will be coming back to. You see our science practices. This investigation lends itself to a wide variety of science practices, collecting observations and measurements as evidence, collecting data. And then this one's huge, the use of science tools, such as graduated cylinders, digital scales, and notebooks. When you were gathering the items for today's PD, you had to gather a lot of things, right? And so this is tool heavy, which is fabulous for our students to have these hands-on experiences with these items. So then we come to our recurring themes and concepts. Two main recurring themes and concepts jumped out at us for this exploration. The first being cause and effect. We feel that's pretty self-explanatory with the adding and removing of heat, right? A more of a stretch might be the stability and change. And so I'm not going to dive into these too much right now because at the end of this investigation, I'm going to ask you to make a connection. So after this investigation, you will have experienced it, and then I'm going to pose the question to you, how was this investigation related to cause and effect? And how was this investigation related to that RTC, stability and change? So keep those in your mind. I'm going to be asking you those questions when this is all said and done. Okay, let me move that bar really quick. So to carry out this exploration with our students, we have student materials and we have teacher materials because there is a teacher-led component to this. The majority of this explanation is student-led, but there is a teacher-led component. So for our kiddos here, you see the graduated cylinders, the triple beam balance or digital scale, the water, and the freezer. So you're going to want to have the first three items per group. And then later on in the investigation, you'll take all their cylinder Bs and you'll place them in the freezer. So that will be to come. For your teacher-led component, this is where the hot plate comes in, right? Obviously, we are not going to let our students use the hot plate. So that is going to be a teacher-led demo. You will need a prepared graduated cylinder with 25 milliliters of water already in a freezer, frozen, to go ahead and carry it out. So you need to prep one of those ahead of time, okay? And then you'll need your hot plate, a pot or a pan, whichever you have to go on top of the hot plate, and then a funnel. You're going to use that funnel to then take what liquid remains and pour that back into your graduated cylinder. So if you also want to do like mitts or whatever, like cooking mitts to keep your hands safe, whatever makes you feel most comfortable, you're welcome to do that. And it would probably be good to show our students that we're using items that keep us safe, right? And goggles, wearing your teacher goggles while you're carrying this out would be awesome. Okay, enough talking from me. We are here in the day one setup. You guys have these materials. So in just a moment, I'm going to talk through this and I want you to do this off to your camera on the side. Okay, you're going to do this with me as we carry this piece out. So I am going to, let me click the right buttons here. Click here. Oh, why aren't you going? I'm just trying to double my screen. Windows key. Put that away. Thank you for bearing with me. Amy, save me.
Windows left arrow.
I was doing the carrot, that's why. Thank you, Amy. Ta-da! See, that's what friends are for. So Windows left arrow. So I know it makes that day one setup kind of hard to see, so you'll have to bear with me and listen to me, okay? So our first step, which I want you doing off to the side here. Can everyone see what's on my camera for the most part? Okay, beautiful. So number one, it says label your graduated cylinders A and B. We're walking our students through this, right? You may want to have these slides displayed up on the screen, or like me right now, I have all of this printed out. Let me put it here so you can see it. I have all of this printed out with my teacher notes. So this is going to be a teacher personal preference. Do you want this up on the screen? You're carrying it out, this Canva, or do you want to print out the teacher notes in this sort of way and carry it out? So that's going to be a choice you'll make. So step one, we're going to label our graduated cylinders A and B. So please go ahead and do that off to the side for yourself. And with the magic of television here, I already have mine labeled with 25 milliliters of water. But if you don't already have yours, you are going to carry out step 2, which says to fill each graduated cylinder with 25 milliliters of water. So if you can take a moment to please do that. This is a perfect time to talk to our students about this tool, the graduated cylinder, showing them the different markings of the graduated cylinder. On the 50 milliliter graduated cylinder, it jumps by increments of 10. So it has 10, 20, 30, 40, 50, right? And then pointing out to them those little hash marks that aren't labeled and how to understand what those lines mean, what those values are. So you can liken this to when you teach your students how to read a thermometer, or when you teach them how to read a ruler and what those little hash marks mean. So by this point, you should have your graduated cylinders filled with 25 milliliters of water. So the next step that we're going to carry out, it says find the mass of each graduated cylinder and record that in your science notebook. So I'm going to get my digital scale. Pardon me as I move these to the side here. And so you can see my digital scale there. And I am going to find the mass. I already know the volume of each of these, right? I filled them with 25 milliliters of water. So I already know the volume. I need to find the mass. So I'll take graduated cylinder A, and you please do this in your area as well, so you have the experience. You'll take graduated cylinder A, place it, and here I see it's 49.3 grams. So I'm going to show you my teacher notebook in just a moment, but I'm going to write that down, 49.3 grams. And then again, I need to find the mass of graduated cylinder B. So I'll remove A, make sure I have zeros on my scale. And look, y'all, I did it perfectly. It's 49.3 grams. I promise you that will not happen, probably. I have terrible luck, and that's all of my luck for the year right there. So if you find the mass with your students and they're a little bit off, just share with them like I may have done an extra droplet of water, right? So we'll write that down in our teacher journal, 49.3 grams. And again, we know our volume is 25 milliliters of water. So I'm going to take my camera for a moment and show you my teacher journal. Pardon me, I don't want you to get seasick. Okay, so here on the left-hand side of my screen, you see we have an image in the Canva to support you in doing this with your students. And I purposely wrote it a little bit different here in my notebook because I wanted you to see, as long as we're tracking the same information, how you choose to set it up is up to you and your teacher style. So I have my title, I have my question, and then what I was writing down off to the side when you could not see was our mass and our volume for graduated cylinder A, and then our mass and our volume for graduated cylinder B. So remember, this is the step. These are the steps you're taking your students through for day 1 setup. So we get to step 4, and it says, what do you observe about the water in the graduated cylinders? Record your observations in your science notebook. And it gives you this sentence stem, I observe. So what I want you to do is in the chat, go ahead and use that sentence stem and tell me, what do you observe about the water in the graduated cylinders you have in front of you?
I observe that the graduated cylinders look equal.
Perfect. And that's key for this investigation.
I observe that the water is the same amount and is the same color. Although one of my graduated cylinders is not clear, so the water appears cloudy.
Oh, I like that.
I observe the graduated cylinders have an equal amount of water. I observe the water is the same amount. I observe they have the same volume.
Perfect. Yes, all of that is absolutely perfect. And I like that you talked about one of my graduated cylinders as cloudy, because if you look here at both of our graduated cylinders, one's a little yellowy and the other is a little more white, right? And so those are noticings your students might make. And so you can share with them, yes, that's a very good noticing. Do you think that's going to affect our observation? And just pose that question to them and see what they say. Will it affect our observation? No, it won't. But that is a very valid noticing on their part, right? So when we go back here, we go to step 5, it says, what will happen to the water in graduated cylinder B when I put it in the freezer overnight? And then it provides us with an I predict sentence stem. I want you to record your observations in the notebook. So here in my notebook, I have that I predict sentence stem. So you guys are teachers, you know what's going to happen, right? When I put that graduated cylinder into the freezer, the water will... Who's the first person who can type it in there? Who's the fastest typer? Tell me in the chat. Oh, expand. Why? Yep, I predict the water will get very cold and maybe freeze. Yes. So remember, I'm talking to you as teachers right now, right? This is the explore. So we wouldn't tell our students, yo, when I go put this in the freezer and I pull it out, the water is going to freeze and it's going to expand, and it's going to do all these things. We're just talking about this together because we're teachers and we want to make sure that you have that background content knowledge. So you are just going to let your students make their predictions there in their journal. And just see kind of what their knowledge is, what currently exists in their background schema as far as frozen water is concerned. Okay, so that is day 1 set up. Let me look here, make sure I have my correct screen up for you. So I'm going to minimize this one real quick and make this one larger. So you can see here, I'm moving on to day 2. This is a 3-day exploration, okay? So we're now transitioning into day 2, part 1 of the explore. We're going to find, it tells us right here, we're going to find the mass and volume of graduated cylinder A and B and record those in our notebooks, okay? And so let me transition real quick. Look at that. I'm getting pretty good at that. So in our notebook, it might look something like the image you have there in the Canva, or it could also look something like this, or, you know, whatever you as the teacher and your style, whatever you see fit, as long as we're tracking that data. So the day 1 explore part 1. Do you see my little 1 that I wrote right here? I wrote that down for you because that refers to, I'm going to bring this over here so you can see, that refers to step 1. So I want you to see for my explore part 1, that piece is step 1. So where it says find the mass of A and B, you're going to carry that out with your students. And this is when B is already frozen, right? So we would find the mass, we would write it down. Looking at the volume, now, do you see in my notes section here that I now have some information? This is going to be critical to help you, okay? Because leaving cylinder A exposed, it might have some water evaporate, right? And so when you look at the volume the next day, it's possible that it does have less volume. That is no longer 25 milliliters. It just depends on the environment in your classroom. So we note that, we recognize that, so you can talk to your students about that, right? That it may have lost some mass due to evaporation, may have lost some volume due to evaporation, but at the end of the day, it's still a liquid, right? In graduated cylinder A. When you look at graduated cylinder B, here's my TV magic for you. Dun, 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 dun. Let me turn my camera. when you look at graduated cylinder B, it appears to have increased, right? This had 25 milliliters in it. I froze it. And when we look at these water lines, it looks like graduated cylinder B now has more liquid in it. And so we as teachers and adults know that when water freezes, it expands, right? Here is a hot tip, all right? Some of our graduated cylinders we have on our campus are kind of flimsy. You want to make sure you are using these thick plastic graduated cylinders, because if you use one of the flimsy ones, your water, when it freezes, will not only expand up. If you have a flimsy graduated cylinder, it'll expand outward and you won't see this significant change. Does that make sense? Perfect. I see some heads nodding. So make sure you use these thick, heavy-duty graduated cylinders, okay? Not the flimsy ones, so we can make sure we get this aha moment with our kids, because they're going to be like, what? Because you're giving them their graduated cylinders back, right? And they're like, what in the world? I know I only put 25 milliliters in there, right? Y'all can envision all the conversation that's going to happen because of that. So we would find the mass, find the volume, take care of all of those things, like you see here in your notebooks, okay? Then we take care of step 2, which is what happened to the water in graduated cylinder A, and how did the state of matter change? It tells us to record those observations. So here in our journals, we would then record our observations for A. Then it asks us about the water in graduated cylinder B, right? That's the fun one. That's the one that's changed. And so we would talk about that, have our students share, and record our observations for graduated cylinder B. How do you guys feel so far? Tell me in the chat. Does this feel doable so far? Are you feeling comfortable? Yes. Perfect. Okay, I just want to make sure I'm explaining it in a way where we're not confused. Yeah.
Jenna,
Yes.
just for fun, I'm sorry, this is just me. Can you put the frozen graduated cylinder on the digital scale?
Sure. So remember, this is a separate one, so it's not going to be my perfect 49.3 that I used all of my lottery luck. So here we go. Let me turn this camera. Okay, there's my digital scale. Here's my frozen. 51.7. So we can see when I filled this one, it wasn't exactly the same as the other one, right? But in the grand scheme of things, 49.3 compared to 51.7, I mean, that's relatively close in terms of grams, right? And so this is a conversation you can have with your students and talking about the advantages and limitations of models, right? We're talking about a phenomena that happens in real life. And is this going to be a perfect representation of this phenomena? No, unfortunately not. But we're using it to explain the science that happens, right? Okay. Oh, that reminds me. I also want to show you on our observations. So you may or may not be able to see this very well, but as this ice starts to melt, water droplets begin to form on the outside of this graduated cylinder. So that's something you're going to want to draw your students' attention to. This special brain wrinkle, that's what I call something that happens when it's unintended. These water droplets are from the air around us, right? And so that is indeed adding mass to our graduated cylinder. So that might also be a reason we see an increase. So that's just something to kind of keep in mind. It's not like the water jumped out of the graduated cylinder and landed down here. We have water floating around in our air, right? And that water floating around in our air is interacting here. The coolness of that graduated cylinder has caused the condensation to form on the outside of this graduated cylinder. So that's a little something to note to your students as well when you get to that explain piece, that they are seeing that transformation happening right here from water vapor in the air to a liquid on the outside of the graduated cylinder. So that's something that you would note in your observations too, that you see that those water droplets there on the outside of the graduated cylinder. That's pretty cool. I thought that was fascinating. Okay, nerd moment, back to this. So when we are looking at our Explore Part 1, we have record our observations for graduated cylinders A and B. And now we are going to carry out Explore Part 1. You scoot it over here. Day 2. So I'm going to minimize this for a moment so you can see this slide. So day 2, Explore Part 1. This is a continuation, right? We just couldn't fit it all on one slide. That's all it is, okay? And so these are going to be steps 4, 5, and 6 of this investigation. So for step 4, you are going to record what do you think will happen to the ice in graduated cylinder B as it melts. You will have your students record that in their notebooks. And then 5, what do you notice about the graduated cylinder as the ice is melting? That's when we can discuss the water droplets, right? Oh, if nobody noticed it, you can bring their attention to it. Are we going to tell them that it's condensation and it's because the water vapor in the air, blah, 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 blah? We're not going to, because this is an explore, right? We just want them to notice those water droplets so we can talk about it later when we get to that explain piece. And then lastly, this leads us to the teacher demo, okay? So where it has step 6, it says, once all the ice has melted, find and record the mass and volume of the water in graduated cylinder B. Now, taking a look at, oh, you don't have it on my screen yet. Taking a look at graduated cylinder B, is this fully melted yet? No, it's not, right? But I need it to be fully melted to carry out step 6. So what's going to happen here, this is when you transition to the teacher demo. You're going to carry out the teacher demo while you wait for their graduated cylinder Bs to melt, okay? Teacher demo, you guys are going to carry this out, all right? So get prepared. You're about to do a little bit of investigation here. I'm going to put the Explore Part 2 teacher demo on the slides. And I want you to get ready, okay? Make sure you have your graduated cylinder, 25 milliliters. Make sure you have a hot plate, a pan, a funnel. And we are going to leave this up here so you guys with your team can carry out this teacher demo portion as fast as you can, because I know we're running out of time. Questions that I can answer to help you be successful here with carrying out this piece with your team? Okay, if some of you are able to position your camera in a way where we can see you, so we can spotlight you and see the cool things you're doing, and also for our asynchronous people who are going to watch this so they can see it as well, we would greatly, greatly appreciate that. So go ahead, take a moment. I'm going to keep sharing though, because I want you to see these steps. And I think we'll play around. I'll see if we can highlight while something is shared. So get your hot plates turned on, get them warm. I see some cameras adjusting. We're going to take that 25 milliliters of water and put it in the hot plate. Now, some of you might have water currently, right? I want to note while you're working on this that you want it to be ice and water. So as you took that graduated cylinder out of the freezer and you've been talking to your students, your teacher model graduated cylinder has begun to melt. We want those two states of matter present in your graduated cylinder. We want the ice and the water. the solid and the liquid. So when you put both of those onto the hot plate with your pan or your pot, they are seeing the liquid turn into a gas, right? The water turn into water vapor. But then they're also seeing the solid, the ice, turn into liquid, the water, then turn into gas, the water vapor. I'm gonna see. There we go. I'm gonna bring this over. When I put a spotlight on these teachers here, were you all able to see that? Did your view change?
It ends up shifting the teacher to the first person so we can see it. It's just small.
Okay, what if I go like this? Are they able to see it better?
It looks the same. It's just this, at least from what I can see, it's the small screen at the top.
Okay.
It looks good on my computer.
Yay! All right, all right. So I see these teachers here with their hot plate and their graduated cylinders and their funnel, and they're warming up the substance in the pot. Let's see if I can look at another group. We're going to, oh, here's a good view of our pot on our hot plate. Now, I don't know if it's just my eyeballs, but I think I actually do see water vapor coming out of this pot. You see it? I'm gonna go to another spotlight. Oh, I feel like Melissa, I feel like I hear yours too.
Yes.
Very cool. And I definitely see that water vapor. So, right,
Yes.
this is the talking point for our students. What do they notice? Very, very cool. Gonna do maybe just one or two more. Oh, Dana, I see water vapor. Yay! That's a nice pot, Veronica. That sounds silly to say, but man, I never had anything that pretty in my science lab. Okay, I am going to remove this. Thank you all for participating so you could get that hands-on experience. And when you carry it out with your students, it won't be the first time you're doing it. So that's kudos to you for being here and attending this PD so you can have that experience. Most of us got to just the heating portion, right? What you would then do after that is you would take what's left over in your pot or your pan, and you would then add that back to the graduated cylinder and find the mass and the volume. And in the chat, I want you to tell me, when I find the mass and the volume of the liquid that was left over, am I going to have more or less mass? Am I going to have more or less volume? Tell me in the chat. Right. Yes, Amber. It should be less, right? Because, yeah, both, right? Less volume and less mass. Very good, y'all. Because that water then turned into what? Yep. Vapor, water vapor. Yes, we took that liquid and we turned it into a gas, right? Beautiful job. So this is what you'll discuss with your students, those noticings. We're not telling them. Yes, Dana, it was a lot less, right? So when we carried this out in this room, actually, I was like, oh no, I'm gonna run out of water. I won't have anything to find the mass of or the volume of. So kind of, play that by ear. You want to have at least a little bit left to find the mass and the volume of. Thank you for that. So yeah, it'll be so cool for them to see. I completely agree. So you'll discuss those findings with your students, this wow, aha moment, and really let them lead what they're seeing. Because remember, this isn't our time yet. We're not explaining yet. We're just providing this experience for them. So after we've done that teacher demo, remember, you got to go back. You got to go back to their graduated cylinders. Do you remember back here, step 6, when we said we needed to wait for that to melt for them to carry this out? You'll have to give them the time to find the mass and the volume of their graduated cylinders now that that cylinder B is fully melted. Because we want them to notice what? What are they going to notice about the volume and the mass once cylinder B has fully melted? Was there a change? Someone can tell me you got it. Okay, for the sake of time, I'm going to tell you as teachers, right? When the ice in graduated cylinder B fully melts, oh, that's a good guess, Amber. I like that because I was going to mention when the ice in graduated cylinder B fully melts, technically the volume should be the same and the mass should be the same. But, and this is just something I'm thinking of right now, my graduated cylinder has a lot of condensation on it. So maybe I take this as a moment to find the mass with all of this condensation, and then I wipe it dry and I find the mass again. I wonder, this is just me thinking out loud, I wonder if I would have a noticeable difference there. That might be something to play around with and see. But technically the volume should be the same and the mass should be the same. But since we have the secondary phenomena, I'm going to call it that, happening here, it might be cool to see if that makes anything change. So, yes, thank you, Laura. Yep, it should remain return to the same. So lastly, because I need to stop talking, we get to our discussion questions here, okay? You'll lead your students through this discussion, and we also have the answers for you or some possible responses and teaching points off to the left-hand side here in the notes section for you to feel best prepared to support your students in carrying out this discussion with these discussion questions. Okay, remember the RTCs I mentioned way back at the beginning? I'm going to bring those up for you. In the chat, I want you to choose one, cause and effect, or stability and change. And tell me, how did the investigation we just go through, how does that relate to either cause and effect? Or how does what we just went through relate to stability and change? Show me your connections on those two RTCs in the chat, please. And as our students, as we help them become familiar with these RTCs, this is exactly what we would do with them, right? We would carry out our investigation and ask, how does this connect? We might need to scaffold them a little in making these connections, but you'll be very surprised how quickly they catch on with these RTCs. So I see the cause of heat being added or removed yields the effect of changed states of matter. Yep. Absolutely, because I added heat, the water became vapor. So the cause and effect, the frozen water appeared to increase in volume, right? Because it expanded. Very good. Relate stability and change. because the one that's frozen and then it sits out and melts will return back to the same volume and mass as before. Change because when the water is heated and then put back in the cylinder, its mass and volume is changed. Beautiful. However, you and your students justify it, and it makes sense, right? You are doing it. You are correlating the RTCs to the instruction. It's just that simple. Very good, guys. Okay, Amy, I'm so very sorry. You have just a tiny bit of time. I'm going to stop sharing so Amy can take you through the other pieces that are available for you in the resource section.
All right, very good. So I'm going to share my screen and share with you what is available in your curriculum documents to further support you on teaching this learning target. Can everyone see my screen? Very good.
Yes.
Okay, I'm going to present something. Okay, so starting off with our teacher clarification section. So this is where you'll go, especially just to brush up on the content and the vocabulary. So for this particular learning target with the changes in states of matter, you'll see the definitions and the changes in states for melting, freezing, evaporation, and condensation, and also include some background knowledge with what students go into third grade knowing and some real life examples of those changes in states of matter. So this would be really great to reinforce vocabulary is to point out when you see those changes at school or show them pictures of these changes and then label it in their science notebooks as evaporation, condensation, melting, and freezing. So that's the teacher clarification. You'll want to visit that prior to carrying out the instruction for this learning target to get all of that teacher background information for you to be successful. And then what Jenna just went through for our model teach, that was the chili changes and heat happening. So that was right here is the link to the Canva. And it has the key next to it because that's one of our hotspot teaks that you can support our district goals with this teak. And then the links below are teacher support videos. So that entire lesson that Jenna just went through, we broke it up, but with videos for each of the parts. So if you want to maybe watch again just to review before you carry this out, or if you have a teammate who wasn't present today that you want to see go through that process and really make sure you understand the thinking, then it would be great to watch those teacher support videos. Okay, and then what Jenna went through was an explore and explain. And so she gave the students the opportunity to have the hands-on experience with the materials and the tools and collecting their data in their notebooks for the explore, and then also went through the explain, attaching that academic vocabulary. So as far as what is in your curriculum, there are some additional resources for the explore available through Savas. Now, if you teach through that entire chili changes and heat happenings, you did a great job covering all of that vocabulary. So it's not necessary to go through every single component in Savas, but this is just additional for you to supplement your students' understanding from what they experienced in the chili changes and heat happenings. So for your Explore, you can also utilize the Savas Read About It and the Literacy Station activity, which for third grade is directly in their student consumable workbooks. It has the text and it has the Literacy Station questions. You can also assign that through the Savas platform as well. And on our science site, if Jenna or Kristen, if you can post the link in the chat, if you just need some extra help with navigating Savas or how to assign things to your students, how to make the key ideas presentations full screen, or just Savas components, we have some tutorial videos on our science site. So we'll have those available for you as well. We can utilize this as an additional piece for the Explore. And then for the Explain in Savas, you have your key ideas presentation, which is like the PowerPoint slideshow. And if you download that as a PowerPoint, there's actually teaching notes in the notes section that you can use to guide your students through discussion and things like that. And then the key ideas activity is the worksheet questions and graphic organizers that go with the presentation and the video. So these are all available through the Savas online platform. And then for our elaborate, there is the ice cubes in a bag activity. And so this is also linked in your curriculum where students will observe the changes in states through melting, and similarly to what Jenna did, measuring the mass as well to see that mass was conserved. And then for our evaluate, there is a key ideas exit ticket in Savas where students will draw a change in state caused by heating or cooling. So they can utilize their data that they collected in their notebooks with the chilly changes and heat happenings to support them in that exit ticket. Okay. And then for supporting diverse learners, we have some support through visuals. So these are the vocabulary cards that are available in Savas, which you have on your campus. They are also digital as well. If you go into Savas in the topic launch, that's where you'll find these vocabulary cards for each topic, but they have them for all of the topics and experiences. Also, the sentence stems and frames, you'll notice that within the Canva presentation for chilly changes that Jenna went through, we included a lot of sentence stems to support students as we help them with those structured conversations and talking in complete sentences and including the writing piece in science as well. Okay, I'll hand it off to Kristen for time for questions.
All right, I just see one dropped in the chat. Question: should third graders already know mass and volume, or should this vocab be pre-taught? So, mass, yes. Volume, I think they may not know the actual term volume, so you can just always say the amount of space it takes up and just measure it in milliliters. And so you can say volume, we're going to measure the mass and volume. And for volume, that's going to be the amount of space it takes up. So we're going to just measure the graduated cylinder, and that should be enough. I don't think it's not really something that needs to be taught in isolation. Like, you teach it as they're doing it. So, and then mass, it's hard because mass is very similar to weight, but it's also very different. So, I think would just say, and in science, we're going to measure the mass, which is the amount of matter it's made up of, which affects its weight. So they're similar, but they're different, and just say mass. But I think the kids will correlate it to weight. But if you use the term mass, I think that will be beneficial. But again, I wouldn't teach it in isolation. I would just explain it as they're doing it. Any other questions? Great question. Thank you. Any other questions? Okay, well, that's excellent. Well, with that said, I am going to stop recording. If you're watching this asynchronously, please be sure to go take your quiz and to make sure you get credit. And those of you that are watching live, hang on one second. We're going to drop your feedback and attendance form in the chat.